Okay, in this video we're going to be talking about binomial radical expressions. So we're going to be adding and subtracting binomials, multiplying and dividing. Binomial means two, so we're going to be having two terms. Okay, so when we're adding and subtracting, like radicals, this is different than multiplying and dividing. Multiplying and dividing, all we had to make sure was that they had the correct nth root. When we're adding and subtracting, they have to have the same nth root and they have to have the same number underneath the nth root, or the same number and letters. Okay, so nth root meaning these threes, or in this case, these twos. Okay, so for adding and subtracting, they have to have the same nth root, and you're just going to follow suit with the coefficients. So if they're the same, my coefficient here is a 1, so 1 plus 3 gets me that 4 in the front end. Okay, my other one is like a 1 sitting out here, so 1 minus 5 gets me negative 4. Okay, and then I got a 1 out here, so 1 minus 8 gets me that negative 7. And then we just keep this back here. Okay, so this is just the rule. They have to have the same nth root and the same little x here, and then we would add or subtract our coefficients normally. Okay, so first off, they have the same nth root. They have the same thing inside the root, so I just subtract normal, so 3 minus 2 gets me 1. Okay, so this one, they have the same nth root, but they do not have the same thing here, so we cannot simplify anymore. Okay, they don't have the same nth root this time, so we cannot simplify. It is in its most simplified form. Okay, they have the same nth root, but they don't have the same thing under here. So what we need to do is find a way to see if they will have the same square root. Okay, so if we broke down 12, what is something that when I square it, it is square rootable? So if I do this, I could say 4 times 3. Square root of 4 is a perfect square, so we should be able to square root it. 75, a perfect square that goes into that, is 25. And then I can't break the square root of 3 down any further unless I have a decimal, and this is 25 times 3. Okay, so the square root of 4 is 2. The square root of 25 is 5. So now they're all in the same term, so I can add and subtract. So 2 plus 5 gets me 7, minus 1 gets me 6. Okay, this one, I have two binomials, so what we're going to have to do is FOIL. So you could FOIL, use distributive method, or box it up. So if I FOILed, I'm going to multiply the coefficients and multiply my square roots when I have them. So I got 4 times 5 right here, so 20, plus O stands for outer, so I got 4 times 4 square root 2. I stands for inner, so 2 square root 2 times 5. And L stands for last, so 2 square root 2 times 4 square root 2. Okay, so we multiply coefficients and then multiply the radicals. So I got 4 times 4 to get 16. I don't multiply this 4 inside my radical. We only combine regular radicals, okay? 5 times 2 gets me 10. Multiply the coefficients, so 4 times 2 gets me 8. The square root of 2 times the square root of 2 is the square root of 4. So it looks like these are like terms because they both have the same nth root and the same thing underneath it. So it becomes 26 square root of 2 plus 8 square root of 4 is 2. And since they're still being multiplied, we still keep multiplying them. So then if I simplified that, we would get 16. And then we can combine these to get 36 plus 26 square root 2. Okay, these could be flip-flopped in order. I don't really care. It means the same thing. Okay, so if we're going to FOIL again, I have 3 times 2 to get 6. O stands for outer, so we multiply the coefficients, so 3 times 4 to get 12. I stands for inner. Ooh. Multiply the coefficients, so 2 times 2 gets me 4. And L stands for last. Multiply the coefficients to get 8. Square root of 5 times the square root of 5, so 5 times 5 is 25. We can combine these to get 16. Square root of 25 is 5. 8 times 5 is 40, so we're going to change that to a 40 so that we can then combine these to get 46. So 46 plus 16 square root of 5. And then we cannot combine those because this does not have a square root of 5 attached to it. Adding, subtracting, they have to have the same radical and thing underneath the radical. Okay, so we're going to FOIL again. So my first 5 times 5 is 25. O is outer, so we get just 5. That's like 5 times 1 because the coefficient that sits in front of here is a 1. And then we have inside, so negative square root of 7 times 5 is negative 5 square root of 7. And then last, I got negative square root of 7 times a positive square root of 7, so negative square root of 7 times 7 is 49. So we're going to change that 49. If I look, 5 minus 5 cancels, so that just goes away. And then the square root of 49, is 7, but we still have the negative in front, so it just becomes 25 minus 7. Which is then 18. Okay, so if we have the same thing written twice, but one's positive, one negative, your center is going to cancel. So first, 6 times 6 is 36. Outside, 6 times 1 to get 6 square root 12. Inside is a negative 6 square root 12. And last is a negative square root 12 times 12 is 144. These guys cancel because they're the same thing, but one positive, one negative. Square root of 144 is 12, so then we just have 36 minus 12, so 24. Okay, this one, my rule was we needed to get rid of the square root on the bottom. So what we're going to talk about is multiplying by the conjugate to get rid of the square roots. So if you think back to when we were doing imaginary numbers, we were multiplying by the opposite sign. So what we're going to do is the exact same thing. So I'm going to multiply by square root of 5 plus the square root of 2. And we can only multiply by a form of 1 to not change the problem at all. So it's going to be on the top as well. Okay, so to multiply the top, what we're going to have to do is distribute this 3 square root 2 in. So I'm going to distribute it to this guy. So I multiply my coefficients, so 3 times 1 gets me 3. Square root of 2 times the square root of 5 is square root of 10. Remember, we can multiply those. It's adding and subtracting where they have to be the same. So my next one, I got 3 times 1 again, so 3. 2 times 2 is the square root of 4. The bottom now we're going to have to FOIL, so I'm going to change colors here. So my first, square root of 5 times the square root of 5, that's the square root of 25. I got outside, so square root of 5 times the square root of 2, so square root of 10. Inside, we have negative square root of 2 times the square root of 5, so negative square root of 10. And then my last is negative 2 times 2, so 4. So if I go in simplifying, this right here, square root of 4 is just 2, so I'm going to simplify that to 2 plus 3 times 2, over, it looks like my bottoms here cancel because one's positive, one negative, and they're the same thing. Square root of 25 is just 5, square root of 4 is just 2. So we simplify again to get 3 square root 10, 3 times 2 on the top is just 6. 5 minus 2 on the bottom is 3. And then it looks like both of these on the top are divisible by 3. Do not divide the radical. This is like when we're doing quadratic formula, do not take 10 divided by 3. It's only the coefficients that you divide the 3 by. So 3 divided by 3 is 1, so I just get the square root of 10. Plus 6 divided by 3 is 2. The thing that's hard about these is you have to keep simplifying all the way to the end. You need to get all the way to the end and make sure everything's simplified before your answer is complete. Okay, so this time the conjugate, zoom in here, is going to be square root of 3 plus the square root of 5. Square root of 3 plus the square root of 5. Remember, same on top and same on bottom, so we got to distribute this in. So 2 times 1 gets me 2. 7 times 3 gets me 21 plus 2 times 1 again gets me 2. Multiply the radicals. 7 times 5 is 35. When we do the bottom, square root of 3 times the square root of 3 is the square root of 9 because 3 times 3. O is outside, so 5 times 3 gets me 15. I is inside, so it's now a negative square root of 15. And L stands for last, so minus square root of 25 because 5 times 5. Okay, doesn't look like we can simplify anything on the top right now, so I'm just going to rewrite it. The reason we multiply by the conjugates is because this will go away. Square root of 9 is just 3, and square root of 25 is now a negative 5. We can simplify again. 3 minus 5 is negative 2. It looks like both of these are divisible by negative 2. Okay, so this becomes 2 divided by negative 2 is just negative square root of 21. 2 divided by negative 2 is negative square root of 35. We cannot combine these because adding and subtracting, they have to be the same to combine them. And we can't break down 21 and 35 any further. Okay, we're allowed to have negatives out here as long as it's not a negative square root. So like a square root of negative 6 we can't have because that would be an imaginary. But we can have them sitting on the outside like that. Okay, so this time we're multiplying by 3 plus the square root of 6. 3 plus the square root of 6. So if I distribute, I get 12x. And then 4x times square root of 6, nothing can go in the radical, so we're just going to put 4x square root of 6. We're just going to attach that square root of 6 on. We're going to FOIL the bottom, so 3 times 3 gets me 9. Outside we get 3 times 1, so 3 square root of 6. Inside we get the negative 3 square root of 6. And my last negative 6 times 6 is 36. Okay, I cannot combine my top because it doesn't share the square root of 6 right here. They have to share, remember, to add and subtract, they have to have the same square root. Okay, so we're going to leave our top. I got 9, my centers cancel, minus square root of 36 is just 6. We can simplify that to get 3. And 4 will get divided by 3 if I wanted to simplify further. Is going to get me an ugly fraction. So we're just going to leave our answer like this.